right, the word game changer is probably overused. But if I had to pick just one ag technology today that really fits that description, it's what plant breeders are able to do with modern gene editing technology.
Using the kind of tools that are available with knowledge of the genome and these kind of data-centric tools, whether it's AI or just good old data mining, we had a hit rate of somewhere in the 70% range of finding the right genes to cause the phenotypes.
That's Dr. Tom Adams, CEO of Pairwise, where they use this technology to make crops easier to grow and easier to eat. He shares several examples of how they do that today in crops from corn to cherries to blackberries.
You know, they're gigantic brambles. We've turned them into little bushes and made them so they flower earlier and more compactly, so you can grow them a lot more densely and get higher yields. We think we can do all those same things with cherries.
On a past episode of this show, I called Pairwise the Willy Wonka of agriculture, and I think you're going to see why. But this technology still has to be fully embraced by farmers, regulators, and consumers.
If you want technology to be accepted, the technology has to do things for people that they understand. And you need to be transparent about it.
Dr. Tom Adams of Pairwise on today's Future of Agriculture podcast. Hello, fellow ag nerd. Thank you so much for joining me for another episode of the Future of Agriculture. My name is Tim Hamrich, and every week you and I get to hear from the founders, farmers, innovators, and investors, the people shaping the future of the ag industry. And I'm excited to share this one with you here today. I've wanted to get Tom Adams back on the show ever since I had the chance to interview him at World Agritech in person a couple of years ago. That interview was included on episode 412 of this podcast called Biological is Not a Category. The work Pairwise is doing, to me, is just mind-boggling. Using CRISPR and the latest in gene editing tools, they've built a proprietary platform that enables plant breeders to make really precise changes to the genome of a plant, which in turn gives farmers and consumers more of the types of qualities that they want. Now, this is different from genetic modification, or GMOs, because they are not inserting a foreign gene into the plant in these cases. In fact, they're doing basically the exact same thing that plant breeders have done for over a century. They're just able to do it in a more precise way, like extremely more precise. On another podcast I host called AgriScience Explained, Corteva's Reza Rasulpour explained natural breeding as wanting to change one word in a book by just combining all the pages of two different books together and hoping that the word changes. Of course, there'd be a lot of other changes along the way with that. Versus gene editing now, which is just going in and being able to edit that one word in a book. So I thought that was a good analogy, a good comparison for thinking about the differences in precision we're talking here and what a game changer that is for all of us in agriculture and really all of us who eat. So Tom and his team are bringing this technology to agriculture by working with seed companies and other partners in a variety of use cases, many of which we're going to discuss here today. Before we do, though, a little bit of background on Tom. Dr. Tom Adams co-founded Pairwise and serves as Chief Executive Officer. He has over 25 years of leadership experience heading up biotechnology for global companies, serving most recently as the Vice President of Global Biotechnology at Monsanto, where he led the team developing a broad range of innovative products. Tom wanted to realize the possibilities of CRISPR and gene editing in plants and co-founded Pairwise to realize this potential in a mission-based environment. Formerly a faculty member at Texas A&M University, Tom holds a PhD in microbiology and plant science from Michigan State and a bachelor's in botany and plant pathology from Oregon State University. Today, Tom and I talk about Pairwise's continued work in this area of gene editing, some of the really cool developments that are underway, also some of their strategic decisions like going the partnership route rather than being the seed company themselves, a little bit more about how the technology works and how this changes the game for those who can capture the value. Enjoy this conversation with Pairwise CEO Tom Adams.
We've developed our platform around the CRISPR technology that, of course, was discovered in the early 2010s by a number of players, but predominantly by Jennifer Doudna, and then has been evolved to be used in crops. And we've done a lot of that evolution to use in crops. So, CRISPR is a technology that allows you to make relatively precise changes to genes, which is a real step forward from the what's conventional now, GMO technology, where you're bringing in genes from other organisms. You're actually able to use this technology to tweak the genes that are there, and typically tweaking them to be just function similarly to how they already function in some varieties, but you can bring varieties together more quickly. So we've been able to use this technology to take the pungent flavor out of mustard greens. We've used it now to take the seeds out of blackberries and also to make much higher yielding berries. So it's a pretty diverse technology. We've also used it a lot on the big acre crops like corn and soybean through our partnerships with Bayer and now with Corteva.
Yeah, I thought that has been really interesting. And has that been part of the vision from day one to apply this to both kind of your, what a lot of people might call specialty crops or high value crops, as well as your more broad acre crops?
For sure. That, the part of the idea behind Pairwise when we formed it was it's time to use technology across all of agriculture and not just for corn, which is, what happens with most things, because that's where a lot of the profits get made by the big seed companies. And we thought really a driver of acceptance of technology is to do things that benefit people in a direct way. Certainly the things that we do with corn are beneficial to people, but people don't feel those benefits in a direct way. So we really wanted to broaden into other crops. We've changed a little bit through the years, because originally we thought about taking the non-big acre crops and actually bringing the products all the way to market. But we've recognized over the last couple of years that it's a much better opportunity. We can use the technology in many more places if we partner with other people like we do in corn, other people who have the capability to bring it to market, and we develop the traits and the crops. So it's been a pretty exciting journey over the last couple of years.
And with that, for you to apply this technology to a crop, do we have to have kind of the full genome sequenced? And do we have that for all crops? Because my understanding is it's been relatively recently that we've had it for like humans, for example.
Yeah, well, relatively recently, but actually in technology, I guess a long time ago. That it's been 20 years since the Human Genome Project was done, and corn was done right around that same time. And it used to cost millions of dollars and take many years to do that. But the technology that's been developed around genome sequencing has been pretty phenomenal. And you keep thinking it's going to top out, but it gets faster, cheaper, and better every year. So that when we started the company, we knew we were interested in caneberries and blackberries. So we did sequencing just on a few of them really deeply to get a complete genome. But then we did like 300 different accessions of caneberries where we did what's called a deep sequencing. So like 40x that you could compare to the reference and see the variation. So we've actually been able to use that kind of variation to find genes. Like we found the gene involved in thorn production by looking at thornless berries and finding the mutation that's not in the ones that still have thorns by just comparing these genomes. And that's something that's accessible to a company that's living on venture capital money. It's not that expensive anymore.
That's incredible. So it's your company that's actually finding something like the gene that causes thorns to develop.
One gene that we found, yes, the gene that's typically mutated in caneberries. I think there's actually a different gene that was found in roses by some academic scientists. But yes, you were doing that kind of and with the AI tools now for analyzing genomes and protein structure, et cetera, you can get into some really deep design efforts. It's not just cut and pray like we do with chemicals.
Well, I mean, it's incredible. I mean, it really, in a podcast focused on ag innovation, we always talk about being on the frontier of things, so much so that it becomes a little bit diluted. But you guys really are discovering something very pivotal for the first time. I'm curious with the genes, how often is it like there's one gene that influences this and we can kind of, turn it off and on or tune it to our liking versus, hey, it's actually several genes that all have an impact on whatever trait or outcome we want?
Yeah, there's a couple of angles to that question. So, most organisms have at least two copies of the gene. So you'd actually have to modify both copies or create some form of a dominant mutation. But if you start moving into blackberries, for instance, they actually have 4 copies. So even if you were just altering one gene, that means you have to do all 4 if you're trying to eliminate it. Some of the traits like thorns, they're single genes that if you eliminate them, you get rid of the thorn. So there's more than one gene in that pathway for sure, but there's one gene that's a regulatory gene required for that. We've removed the hard coat around the seed in blackberry, so we made what we call a seedless blackberry. And for seedlessness, there's a couple of different genes that we had to alter to get rid of that hard coat around the seed. So now it's soft seeded, just like a seedless grape, it's pretty interesting. Those will be a couple of years before they're in the market, but we've now got them in field tests. We'll have our first field grown seedless blackberries this coming summer. So we're quite excited to be able to see and taste the ones that are coming out of the field. We've only had them from controlled environment so far. And then there's other traits that, certainly fairly small numbers of genes can have pretty big effects if you move into the regulatory pathways that are controlling things. So in our collaboration with Bayer, we've had two collaborations. Our first we call Bayer 1.0, where it was fairly broadly across most of the big acre crops. We actually delivered to them 28 different traits that they have at various stages in their pipeline, and in corn, cotton, canola, and wheat. So traits in different ones. And some of those take more than one gene, but a lot of them are single genes. And, using the kind of tools that are available with knowledge of the genome and these kind of, data-centric tools, whether it's AI or just good old data mining, we had a hit rate of somewhere in the 70% range of finding the right genes to cause the phenotypes. Of course, then there's a lot more work to turn that into a product that's going to be sold, but it's to get that initial phenotype is pretty straightforward, or has been pretty straightforward for us.
And I think that brings up a good point, which is, Pairwise, to my knowledge, is not actually turning around and selling seed, right? You're partnering with a company, like in this case, Bayer, that uses the trait to incorporate into their seed offerings. And I know you all have what you call your Fulcrum platform. Is that essentially that platform the way to identify those genes that want the phenotype you're after, and then kind of also take it to the point that it, develop it into a trait?
Yeah, you got to call things something. So it really is the all-inclusive term that we use for our platform. We've licensed our editing tools fairly broadly to people. I think we have more than 10 different licensees now. We call that Fulcrum, but typically some of those include some of the gene identification piece, but a lot of those are strictly the editing tools. But the whole platform is what we tend to refer to as Fulcrum. And there are different aspects of that, some of which are easier to transfer to other people and some of which work better in a collaboration like our collaboration with Bayer, where it's kind of hard without transferring the person to transfer the knowledge of how to use things.
Right. And when we spoke almost 2 years ago now, I know you had mentioned some work you were doing on pitless cherries, and I thought that was an interesting example. Since then, there's been press come out on that and a partnership. Can you just give us an update specifically on pitless cherries?
Again, going back to our premise and starting up the company, we were looking at different types of things that we thought could really drive consumer acceptance and that consumers would like. And if you look across produce, loss of seeds has been a driver for, whether it's seedless mandarins, seedless grapes, et cetera. It drives both some premium pricing, but even more importantly, consumption goes way up when you get those kind of traits. So that was exactly the thesis we're playing into. So we were thinking about things that we could work on. And I love cherries, but I don't really like, after I eat a few of them, my fingers are all red. And I didn't do this. I did other things when we had young kids, but my wife would always cut them open and cut the pits out because I guess people are afraid their kids are going to choke on the cherry pit. So it seemed like, if you're going to take something and make it more convenient, why not make a pitless cherry? So it was, from fairly early on an interest of ours. And we started doing kind of side work because trees, you figure, take a long time to work on. So we were working relatively to the side. And then as we got the success in the blackberry, that same pathway is what we expect we'll be able to make a pitless cherry. And there's some other things that we've done in blackberry. We made blackberries so they're, I don't know if you've been out to pick blackberries outside, but they're gigantic brambles. We've turned them into little bushes and made them so they flower earlier and more compactly, so you can grow them a lot more densely and get higher yields per production. And we've done that now in the field this past year, so quite excited about that. But we think we can do all those same things with cherries. And so does our partner now. Sunworld has joined us on this. And we've already made a cherry tree that makes ripe cherries on it about 14 months after you plant the tree, which, normally in an orchard, that would take probably more like 4 years before you get your first cherries. So we can speed up the production of the cherries. But also, if you want to make a pitless cherry, you've got to start by making cherries faster so you can actually get feedback on the edits you're making. So we're now in the process of making the edits that we think will get rid of that pit in the cherry. So stay tuned. But a few years from now, I think you'll be able to get a cherry without a pit. And then, the beauty of that, just like I said, going from blackberries to cherries, why not go to peaches and plums and then start moving out of into other genera like the avocados and the mangoes? And, there's a whole slew of things that still have that pit that has various barriers for people to eat more of those fruits.
Right. And I think there's a great example for people to understand gene editing too, because, well, I grew up in Sonoma County, where Luther Burbank is from, the gardener touched with genius that, developed a bunch of different kind of fruit varieties. People have been working on this for a long, long time. We have examples of crops that have been developed over the years. So it highlights the fact that this is something that we've been trying to do for a long time, and we're able to do it now with technology, but it's a natural outcome that could exist through conventional breeding means. Is all that accurate?
Yeah, and I think you probably didn't realize this, but Luther Burbank actually bred a plum that was essentially pitless, but it's a very complicated set of things that he brought together through breeding. So it's not something you can easily move into other plums. And I think it's actually been kind of lost to posterity now, but he actually created a pitless plum through traditional breeding. But what we can do with the CRISPR tools is we can do that in a way that's fairly specific, and you could, quickly move it through other varieties and things as well.
It's incredible. And then you'd mentioned earlier, I think 27 or 28 traits delivered with the first Bayer partnership. I mean, similarly, I assume those are traits that they had been working on themselves and investing a lot in trying to figure out that basically gene editing has just been able to accelerate this process.
Yeah, exactly. In fact, our Bayer 2.0, so our new relationship with them is focused on creating a gene-edited version of their short corn product. So we're using the tools now to create different versions of shortness. We've actually already created some really interesting things that we've handed off to them. What's happening with gene editing, because you're doing something that's natural, the endpoint is natural, it's something that's already there. You're not putting something in the crop that wasn't there before. Most jurisdictions have basically said this is a product just like a breeding product, and therefore, while you still have post-market regulations like any food, you don't need to have these special pre-market hoops to jump through that we do with GMOs, which I think is a big advantage. And given the challenges we have with the food system, it's really important that we are fast and quick in getting these kind of improvements out.
Right. And one of the questions that I was going to ask you, but I think you really already answered, is kind of how much of the value here that you're offering is accelerating the process versus getting us somewhere that we could have never got without it. And it sounds like everything theoretically would be possible without it because it is a natural outcome. Is that right?
Yeah, I mean, just to go back to my pitless plum story, plums and cherries can actually be crossed. So you could take that pitless plum and you could cross it with the cherries, but because it's multi-allele, multigenic, and it's it takes a long time to keep the cherry flavor that the parent had. It's probably 200 years of back crossing to get the pitless cherry to still taste like a cherry and be pitless. Yeah, maybe get some interesting intermediates, but to get all the way to the true cherry again would take you a really long time. Another real example is blueberries. I have blueberries almost every day now. And that wasn't true when I was your age. I was having blueberries, every now and then. But some forward-thinking breeders started now it's probably 80 years ago, started breeding southern varieties and northern varieties. And it took about 60 years, and they got varieties that could be grown in different climates and still tasted like a blueberry to be grown year-round, and you get a year-round supply of blueberries. You could do that now in probably 10 years by taking a variety of blueberry and just changing the same kind of genes, but doing it more directly, while maintaining the flavor of the blueberry, which is kind of the secret. Is you don't have to have 30,000 genes segregating. You're just changing one or two.
Right. And the blueberry story is incredible because part of the reason that hasn't happened in crops outside of corn and soy is that the market isn't there today. So like for a company to go on that journey, if they, I can just imagine the breeder saying, I need money for 60 years to work on this, and then I think we're actually going to have a good market. It would never happen. And I think that's definitely part of your story at Pairwise, is you can work on those crops that you sort of have this chicken and egg problem. It's like, yeah, we could have more acres if we had better varieties. It's now much more economical and time efficient to do that.
Yeah, I think that's exactly right. But it's still, it still leaves a lot of room for the university breeders who have been real. Their talent has been very valuable to us having great produce all year round.
Absolutely. Yeah. Well, and another part of the story that I find interesting, and this may be, sometimes I make up narratives in my head. Problem about being a storyteller is you can convince yourself of anything. But it seems to me like there's an opportunity here with gene editing to shift some of the value of the food dollar back to the farm, meaning we right now have to take whatever we grow and connect it to whatever consumers want. And that process of connecting it is food processing, whatever the case may be, turning that raw product into what consumers want. But through this, could we maybe get our crops to be grown more straight out of the field the way consumers want them, whether it be a pitless cherry or something else? Do you see that kind of happening in the future?
So I think there's a lot of value to be created for all of the participants in the supply chain, and including we certainly believe the technology provider, there's enough value that we can create that we can get some of that. But then, each of these crops is very different how they get to market. And that's, one of the fascinating things about agriculture. It's not just one route. So the way corn goes to market and the way grapes go to market are quite different. And I think that the growers in specialty crops or in fruits tend to do okay today, especially in countries where labor is maybe available. In countries where it's less available, it can be challenging. I think we do think that we can address some of those challenges for growers, like to make it easier to automate a crop, automate picking of a crop, that sort of thing, by changing the architecture. So I think there's a number of things that could make it even more sustainable for the grower. But then you also need the packer shipper to be successful and, helping with shelf life for that packer shipper. And ultimately, we really like to think about the consumer, because the consumer it might not be our direct customer, but it is the customer of the endpoint. And I think we can make things where the consumer both gets a more nutritious meal and more variety.
Right. And I know you and I talked last time about how important it is for this to show benefit to the consumer, as opposed to only be, beneficial for the producer and the consumer downstream, but not see that value. They can actually see the value of something like this.
That's, again, I think I've sort of said that as sort of one of our original beliefs is that if you want technology to be accepted, the technology has to do things for people that they understand. They don't need to understand the technology. They need to understand what it does for them. And you need to be transparent about it, which we've, continued to maintain this kind of a idea that we don't want to hide that gene editing was used in this. We want consumers to know that, and they can have a choice, because the non-gene edited products will be there too. They might not be seedless blackberries. There might be blackberries with seeds still. And if you're, uncomfortable with technology being used, that's fine. That's your choice. But we think people should have a choice to buy things that they like.
Mm-hmm. And you made the point about how different the production systems and markets and kind of supply chains of each crop are. Is that kind of why you've chosen the business model of the partnership approach?
Yeah, and we started down the road with our salad greens that we were thinking we might market as conscious greens. And we quickly recognized that before you know it, you're a salad company and you can't do all the other things that your technology is capable of doing, because it's really complicated to take something from seeds, to plant them, to turn them into a product, and then get them to market. And in produce, that's happening all the time because you've got to have that in the store all year round. So as soon as you start doing that, and that's your job for one crop, it's hard for that to be your job to then work on all the other crops. So we think with a partner like Sunworld, for instance, in fruits, they actually are an intermediate as well. What they do is breeding to create unique genetics, and we're going to work together to create unique cherry genetics. And then they partner with producers and packer shippers to get those genetics to market. They do tend to brand their particular traits. So like the Autumn Crisp grape is their grape, but different grape producers and grape distributors sell the same grapes. They just use them differently. And that way you can get to the whole market much faster than if you're trying to just capture it all under your own brand. So we found that to be, we sort of made this switch a couple of years ago, and we've been able to really create a lot of momentum with a lot of different partners since then.
So cool. Well, this is going to be a pretty open-ended question, but I a lot of times don't know what I don't know. So I like to give you a chance to take it in the direction you want. But are there any kind of underappreciated aspects of gene editing as it relates to what we're talking about here, in crops that we haven't discussed or that people aren't thinking about? Maybe they are thinking about, okay, short stature corn, I like that, less lodging, that's great. Or seedless blackberries, that's kind of cool. But any kind of underappreciated aspect to this?
I think that generally the opportunity with genetics is huge, and it's always been what's driven the improvements in our lives relative to especially produce and food. So you go back 100 years ago and the types of variety that people had. I mean, it's amazing when you go into a supermarket today and you see the variety of things that you can buy in the middle of winter. And that's because of great contributions made by genetics. There's still plenty of things to be done, and we still have lots of opportunity to drive more consumption of healthy fruits and vegetables. And it's great that actually in the world now, I think we're for the first time ever on a trend to have people consuming more and more fruits and vegetables. And that comes from creating more variety as well as more awareness of the health benefits of doing that. So I think what gene editing does and what's important to recognize is it's just accelerating what's happened and what's been so beneficial to us. And who can be against doing good things faster? So I think it's a really great opportunity.
And how accessible is this technology to smaller companies? I mean, obviously you're working with companies of all different sizes, but is this kind of getting democratized, for lack of a better term, enough that a smaller company would be able to develop their own variety?
That's a great question. So I think we didn't set out to do this, but in working to improve the CRISPR technology for agriculture, we actually created a set of new tools that were proprietary to us. There's nobody else's IP that we need for those. And we decided that the best thing that we could do with that is try to make it really easy for anyone who would like to get access to those tools to get access. So we've created a pretty robust licensing program. Again, I think there's probably might be as much as 15 different licensees that we have now, and a whole line of people who are looking at it because we've made it quite simple. It's not expensive. We'd like to share somewhat downstream, but not in an expensive way. So try to make it really easy and not put burdens on people. So we have companies from seed stage companies that really have very little funding that have licensed it, and usually we'll make a commitment to that. We have groups that are NGOs that are really not for profit at all that we've got licenses with, and some universities as well. So we're trying to be a part of that democratization, and so far that's been pretty successful. So we do think the technology shouldn't be the differentiation here. There's so many different things that need to be done to continue to improve crops, and all of that can't sit in one company trying to do it all.
Right. Well, I mean, with your partnership approach, it's cool that you get a purview to so many different interesting things happening in agriculture right now. We're talking early January 2026. As you think about this year for Pairwise and also how this technology is being used, what's most exciting to you about this new year?
2026 is a big year for us. We've got our really robust set of field trials on our blackberries that are going in both here and in South America that will begin to really show the benefits of the improvements, both of the seedless, but also of this higher yielding blackberry. So really excited to see the results on that and see the grower responses as well as with the seedless, we're going to be able to do some taste panels and get consumers feedback on how seedlessness in a blackberry is. So excited to see all of that. And the cherry, which we really just started in earnest a couple of months ago, is already, as I mentioned, we've got these early flowering cherries, and we should be getting the first edits there. So really excited to see that coming along. Really mature relationship with Bayer that continues to create a lot of interesting things. And we're only a little bit more than a year into our relationship with Corteva, which we haven't talked a lot about here, but I think that's a really exciting opportunity to between Corteva and Bayer, we've got relationships that cover, somewhere around 70% of the world's corn acres. So a pretty great opportunity to try to make a big impact on a big crop. And then I think it's going to be an interesting year in agriculture. We're going to see the Corteva become Spinco plus Corteva. We've got, it seems like Bayer's making some really nice progress on solving some of the challenges they've had around herbicides. So I'm excited to see agriculture continue to blossom.
That's great. And I know when we spoke last, we interviewed you with Todd Rands from LO Life. Obviously, you and him had a great relationship, and it seems like it's just a kind of a pretty collaborative space. I wonder in general, is there other applications for gene editing technology in agriculture out there that you find really interesting or exciting?
Yeah, I think it's cool because there's been a lot of these sort of back burner efforts that people have around materials, and it's not just food, it's things and certain food additives. So, whether it's trying to make, modify starches or create rubber in plants, in non-rubber tree plants, latex out of them. There's a bunch of companies that are trying to do those sorts of things. And, certainly we have conversations pretty broadly with different groups. And I think it's something that when you're starting off with crops that aren't really crops yet, they're really kind of wild, and people are trying to domesticate them more rapidly. Some of the tools that you can do with gene editing, there's a lot that's understood about the genes for domestication, and editing can make that really sped up a lot so that you can move something that, again, it would be a 60-year breeding problem into a 5 to 10-year problem.
Right. And for kind of jumping back to the regulatory conversation, as far as like timelines for approval, it sounds like, well, maybe give us a sense, where do we stand now as far as could we get access to this technology in some form right now? And what are the barriers and opportunities ahead regulatory wise?
Yeah, so most of the world has taken a stance that, again, if the product that we make is something that could have been made by breeding, that there's no pre-market regulation. So the only work that needs to be done is to demonstrate that it's something that could have been made by breeding and that you're not leaving any trans genes behind in the material. Well, we've already seen significant progress in Europe, which is the biggest holdout on approval. It's such a complicated process in the EU, but they have actually made it through, 90% of the way now, where the 3 different legislative bodies have all come to an agreed approach to approving certain types of products that come out of gene editing. And they define fairly clearly, but most of the types of things we've been talking about would fall into the exempt category with what they're doing. So I don't think we'll have actual approvals in 2026, but we will have the rules and the finalization of rules. And then the way the Europe works, each country gets to set their own final rules, but there is going to be a path towards products being sold in Europe and grown and produced in Europe. And I think that's really exciting because it opens up, different markets and helps a lot more growers.
Yeah. Tom, I really appreciate the time. This has been great. Anything you want to add or emphasize before I let you get on with your day today?
Sure. I guess what I can give you there is, 2025 has been a really outstanding year for Pairwise. We really turned the corner on product development. We've got our first real fruit products out into the field for field testing and expanded our collaborations by adding Sunworld and really solidifying our relationship with Corteva. Really excited about where that's going to bring us into 2026 and beyond, because it really sets the stage for what I think will be a series of important, impactful products coming out of gene editing, both from Pairwise, but also in 2025, we added a number of licensees who are doing interesting things that are solving other problems in agriculture. So really excited to see how that's going to play out over the next few years.
Well, it really is exciting. And I want to thank Tom Adams for being on the show here today. And I mean it when I say whenever anyone in casual conversation wants to know my thoughts on the future of agriculture and what technology I think will have the biggest impact, gene editing is always at the top of that list. So very, very cool to see how Pairwise is really on the leading edge of this technology and bringing it to market, and the fact that it's happening. It's not something we just talk about in the distant future. They're actually making this happen today. So very, very cool. Thank you again to Tom for being on the show. Last but never least, thank you for your time and your attention. I do not take it lightly. I'll be back next week with another story of ag innovation.